The next presenter is Shane. He did his PhD in Leeds at the University of Leeds under the supervision of Professor Peter Johnson, and he's been at Glaxo for, I think I can say, ages, but he still looks young, so don't worry.
Yeah, thank you for the introduction, and thanks John for kind of giving a good overview of kind of web services and a few reasons why they're quite very useful, particularly to use different languages and things like that. But I'm going to talk a bit about some other reasons why GSK are using web services. We've been writing web services, well, for about 10 years, maybe a bit more. We were doing it probably before some of those standards that John mentioned were even finalised, just SOAP. So a lot of our very old stuff were just plain XML. And if you're lucky enough to be at the US UGM last year, I know Brett, my colleague, gave a presentation which talked a lot about how they evolved over the last 10 years and what we've done to improve them and some of the new technologies we're using and how we try to integrate with various vendors. We weren't really at liberty to say at that time, but now we are ready to say that we have made some big changes to the web services to migrate to ChemAxon. These are probably some of the biggest changes we've ever seen, and I'm going to talk a bit today why or how web services and SOA has enabled us to benefit from that architecture. So I'm going to discuss a bit why we did it and a little bit as well of how that went. So R&D IT have been driving towards simplification of our software portfolio. We have a lot of software in-house that we maintain and support. And there's several fronts that we've tried to push to reduce those costs. One of those is looking at technologies that we use. We are kind of moving toward .NET for desktop applications, thick desktop applications. We are a kind of Windows-based, well, our chemists are using Windows on the desktop. And also for web applications, possibly moving into the cloud as well. Oracle for databases, we've been using them for quite some time now. We have been using Java for quite a while actually, but we are, as I say, moving towards .NET, so we're still undecided yet of how or where we can continue to use Java. So that's one big advantage that obviously ChemAxon are having that .NET availability. We're trying to phase out some of the really old stuff that we're previously trying to integrate with C++ and C code and Fortran, having to do away with that if we can. Again, try and reduce and retire what we have. So we just have far too much software going around. And if we can save on costs to vendors, we do that as well. So this is kind of general overview of some of our web services that we support in R&D IT and that we've written. And you can see in the kind of bubbles where we're using vendors to give us key processes for our chemists to use that are obviously preferred, they're best of breed. As you can see, there's actually quite a big bubble of GSK in-house. That's not only implementing our own algorithms because they're not available in those vendors, but also there's obviously a lot of integration code. We find that some of these vendors, they don't necessarily always be that reliable, so we have to write some code to deal with vendor code crashing. So we kind of put things like process pools into place to deal with those cases, and maybe even export the vendors as their own web service, so it doesn't actually crash our main web service. Okay, thanks. There we go. Where's the? There we go. There we go. But yeah, so that's just a general overview of where we were over the last couple of years, and there's obviously a reason why we chose these vendors and why we've spent money to develop software to integrate them into our systems. I think that, again, if you were at that presentation that Brett gave, he gave a kind of good overview of why we're using these vendors. We need to, well, our systems, we generally save a lot of information in databases as smiles. A lot of catalogs we don't store them in mol file. But the chemists don't want to see mole files, smiles on the desktop, so we have to generate the coordinates automatically for them. So we need a good process to generate those coordinates. We obviously need a toolkit and some cartridge to do any searching and to do any chemical manipulations. And as I said, because we do store a lot of smiles in our databases, a good conversion to smarts is very useful because, again, the chemist won't be writing smarts. They'll be drawing queries which will get exported as mole files. And again, we have several in-house algorithms that we have written natively because they're not available by the vendors directly that we currently have. So we did an evaluation of a number of vendors. Obviously, ChemAxon was one of those. And we found that ChemAxon, it wasn't necessarily the absolute fastest at one particular thing, or it had the best possible, this particular process was the best of everybody else. But generally, as an overall product, it was very, very good. It had all of the things that we needed. It had a toolkit and it had a cartridge, and it also had a number of other products that we knew that we could potentially use and consolidate some of our other systems. As I said before, we're obviously moving towards .NET, and possibly, obviously, I'm sure we'll continue to have Java in our environment for some time, and having support for smiles and smarts, which is one of our major standards that we use. And one of the biggest things that that kind of sold us on ChemAxon was their continued development, and we've been working with them over the last year or two to help improve how we understand the product and possibly help them to improve their product as well. And again, so some of that in-house written code they've got available already inside their product, so we could possibly get rid of that, help us with our support costs so we don't have to keep that going. And performance, we didn't really see any issues with the performance of the ChemAxon cartridge or the toolkit. But something that we do talk about a lot internally is user perception of performance. Not necessarily the time to pull back 2 million compounds, but the time to pull back the first 10. So we're actually looking forward to one of the release 5.4, which we know that Sabosh and his team are working on to introduce some improved performance of those initial results by putting, I think is it multi-threading in the initial fingerprint scan? I think it is, yeah. So we're looking forward to that. So this is our web services to be. As you can see, we've tried to reduce as much as possible our in-house code base by using the ChemAxon's inbuilt. One of those features was our group fragmentation or our group decomposition. We actually had our own algorithm for doing that and our own web service. And now at this time, my developers back at Stevenage are developing a web service that will integrate with the ChemAxon algorithm. We obviously still have some in-house code to deal with things like business rules and legacy information that we have to deal with internally. But for the most part, we'll be using ChemAxon for doing most of that processing. We don't have all of these processing in our production services as yet. We're still working with ChemAxon to make a few improvements before we can push that through. So how? This is, it looks fairly straightforward, but actually there's a lot of back and forth with this kind of migration plan. It's very, very, you could probably make them overlap quite a lot and going back and, yeah. So obviously the first thing to do is figure out where you're using these vendors in your software. We actually have a GSK in-house registry for holding all our software components and dependencies. But unfortunately, it also doesn't always get filled in correctly, as you can imagine. So we try to audit the databases, audit the services, audit the software where we can. And if we think that we've removed all the dependencies from that particular vendor, we can just revoke the license. And if there are anything left, then they'll obviously break, and you'll know about it pretty quick. We do have, obviously, legacy applications that are not using SOA yet, because they were written a long, long time ago, obviously. We didn't have SOA at that time. but rather than try to rewrite them, possibly is one option, but rather than try to migrate them directly to using the toolkit natively or database natively, our preferred solution is to move them over to using SOA. And as John indicated, you could do that from pretty much any language now, which is a big advantage. And our developers are pretty much well informed with SOA and how it works. We have loads of examples of how they can work with it in different languages. Another thing to do is to retire those obsolete services. So you migrate not only from using software natively, but from old services to new services. That's one thing that we do. Simply because, as I said, some of these old services we have, they're not SOAP compliant. So it's something that we can't really support forward-looking. And obviously, we'd migrate all of our web services and our ChemAxon and our databases over to the ChemAxon toolkit and cartridge. So we're actually able, with that cartridge, we're actually able to run our existing vendor cartridge at the same time as the ChemAxon cartridge. And one of the reasons for doing that, I think, was because of the difference in architecture between the existing vendor, which was a native cartridge, and the ChemAxon cartridge actually quite a thin layer on the database, and we actually installed the J server on a completely different server with much more memory, so it could hold indexes in statically. Yeah. So we had a number of objectives, but SOA was able to benefit in these. Firstly, transparency to client applications. You might have quite a lot of client applications. Trying to do it without them noticing that there's a change is not always easy, but with a lot of testing and a lot of discussions and user groups, you can make that happen. Obviously, web services can deal with all the business rules of different vendors behind the scenes, so they don't actually see any difference. The API of the service never changes. And again, you can maintain the business rules in the web service. So we have a lot of automated testing on the web services themselves. So all of our business rules that we predefined previously, we've covered in automated testing to confirm that as we do migrate from one vendor to another, it still maintains those rules. It also means that the client applications don't need to know those business rules necessarily. They probably will test those things, but they don't need to have their own tests internally to cover those. We have all that good stuff actually in the web services themselves. And we can achieve zero downtime. We actually load balance our web services over multiple machines. So we can turn one off and all the rest will continue to run, and requests will get rerouted to the available services. So I think I had a TCO on one of my earlier slides. I don't think I really described it, but I'm not sure if any of you guys talk about total cost of ownership, but it's a phrase that some people at GSK have come to love and some come to hate. It's a general term that indicates not only the cost to develop a piece of software, but also to maintain it and the full life cycle of maintenance, support costs, upgrades, and any other costs you could foresee within a few years. I mean, we cover it usually over 3 years. We do a plan to see what we think that the cost will incur. This is a kind of something that we did to just confirm to us that SOA was the way to go. And we put together some estimated costs of what it would take if we had a traditional architecture. So you have all your applications, and at the time we believe there were 42 applications, software applications in-house that were using our web services, chemistry web services. We'd obviously have to, in a traditional method, you'd have to migrate all 42 applications to using the new vendor and migrate them to using the new database schemas, the new, whether it's the new cartridge. You'd have to do a hell of a lot of testing on every single one of those. You'd have had to have a way to govern and ensure that the business rules are kept on every single one so that they're consistent. You've obviously got additional maintenance and support costs, because if every single application needs to know about the vendor, it adds up quite a lot, and they sometimes need to know the chemistry, obviously, in those cases. But in our SOA environment, all that information is in the web services themselves. We have a handful of web services where as I said before, we have a lot of automated testing, and that's the only thing that we really need to test hard and make sure that that's working as we expect. And then the client applications, it's kind of minimal testing for them. It's just to confirm that it's working as it was. And we do expect some minor changes. I mean, the chemical fingerprints are obviously proprietary, so we're going to see slight differences between vendors there. So that leads to some discussions and tweaking of the configurations to make sure it works as it did before. But yeah, so what we projected is that it would cost quite a lot more to have done this if we didn't have SOA at GSK. So we were obviously quite happy for that reason. This was a case study that I got involved with as we were doing this project. We actually had some web pages that actually used it within another application. And it had a lot of JavaScript in this application. And it was an application where you could click on different structures and it would render them, and you could highlight different things and it would render them dynamically. It was all in JavaScript. And obviously it was generating images of those structures. And something that they liked to do was align them and color atoms and make them bigger and make them small, all dynamically, very, very quick, very, very fast to happen. But obviously, if we were to migrate this over to using kind of thick applications on the desktop, it's very, very heavyweight and can be slow and can cause crashing, and it's much more difficult to support. So the solution was to use SOA to do this. So we generated actually a SOAP and a HTTP-based API, very, very fast because it was using our existing load balancing infrastructure that we have. It was good. It was very easy, obviously, to add new parameters because it was an existing service, and very simple to use. I know that John showed an example using SOAP to pull back an image in a source URL, but we actually have generated a service where you basically pass your structure as an argument. This is the simplest case, but you can. We have a method that parameters allow you to pass coloring information, color atoms differently. It also allows you to pass coordinates for atoms, so you can align it any way you like. You can even, if you're doing a substructure search, pass in your query, so it aligns it to the query. And I think we have a number of other features as well. It's very easy to add and update, and very, very easy for client developers to understand and use. They don't need to think about the chemistry at all. They just need to pass it in, use the service. And one particular use case was alignment of structures. And in the previous mechanism, what they were doing is using, well, firstly, one AJAX call to send off all of the structures and the thing to align it to, which would happen in the background, and it would take some time because it was all happening sequentially. There's quite a lot of JavaScript written to make this happen, and you can see that it's not actually that fast. So if you did want to do it, it was kind of a second thought. Do I want to do this? It's going to take some time, you know. So it's maybe wait until you're on the final set, you're on the final page, and then you'd click it and say, yeah, let's align it. So what we decided to do is actually push that feature into the service itself. And it's very easy to do because obviously it's in the same stack as the ChemAxon toolkit. They're both Java based. Much simpler code and architecture, especially for the client side, because as I said, you're just passing it in as a parameter. You're not actually doing any extra JavaScript. And because it actually made much better use of the load balancing, I'm sure that they could have written the JavaScript in the first example to call multiple times, but again, you've got to write loads of code to do that. But obviously, in our case, you just stick it in the image URL, and you get back images quite quickly, and you use, your browser is allowed to make, I think, 4 by default Internet Explorer connections at a time, so you get back these quite quickly, and load balancing onto different machines, so using the resources quite effectively, and you get much better times out of them. So now they leave that button clicked all the time. Because it happens so instantly, they don't really notice that it's an extra bit of work to do. So just to give you a quick summary, I talked a bit of why we migrated to ChemAxon. There are quite a lot of good reasons to do that, and how we did it, and some of the obviously overlapping we have to do with existing vendors and the way that SOA plays a part in making that easier for client applications so they don't really have to do anything. I mentioned 42 applications in my, my TCO slide, but that was from looking at logs and auditing. We actually found out there's more like 80 at the moment, 80 applications in GSK hitting our internal web services. This is all inside GSK. We obviously, our SOA is led to one place to house all that information, all the business rules. You can easily change it when you need to, and it's consistent, so you're changing it not for one application, you're changing everybody, so everybody sees the same thing. And it saves us money in the long run when we have to deal with cases like this where we're migrating or making big changes under the hood. I guess what might come next is, I think if we're lucky, Brett or maybe Karen might give a talk about how we might be using Instant JChem or JChem for Excel at the next UGM. That's all. Thank you.
Thank you very much, Shane. It was very impressive, and I'm sure we will have at least 2 questions. We've got time for 2 questions. Yes, okay.
So for your migration schedule, you didn't list up how long you think it will take, or did I miss that in your presentation? So for those green parts that follow up?
Mm-hmm. So before we could obviously push anything into the production environment, often it's not the actual technical side of migrating, because we actually found that quite easy. It was very simple for us to migrate. ChemAxon is in the same programming language as our web service at the time, so that was quite simple. It was a much simpler API than our existing vendors. And again, because it was in the same technology, it was much easier than and have to deal with C++ programs crashing, so we could actually get rid of quite a lot of the data and code that we had, and it became a lot simpler. So the technical side was quite quick and simple to do, but obviously the business side of deciding exactly if we can go ahead and looking at the fingerprints and checking the substructure searching took a little bit longer. And obviously we have been partnering with ChemAxon to try to improve where we have our automated testing that obviously fail when we know that ChemAxon isn't doing something that we have previously defined as a business rule. And then it's obviously often the communication and getting ChemAxon to understand what we would like to happen, and our customers, our client applications and developers to understand how things are changing and how things might be improving actually than they were previously. So, I mean, this project, we started it middle of last year, and we're just about to push all of our current web services into production. I think in July we've got our fixed release date to push everything into production, which is using JChem toolkit, JChem cartridge, and actually some new web services as well, which is based on some of the new products such as our group fragmentation, things like that.
Sounds pretty quick.
Yeah, it was.